So, this is the topic of the day, sampling distribution for the difference between two sample means. So, what is this? If you have two populations, for example, population 1 and population 2. Suppose the size of population 1 is N1 and the size of population 2 is N2, right? And if you take a sample from this population, say N1, by any method, sampling with replacement or without replacement. Similarly, if you choose a sample from this population, that is N2, by either method, either sampling with replacement or without replacement. So, you will have so many samples. If you are applying sampling with replacement, you will have N1 to the power N1 possible samples, or if you are applying sampling without replacement, it will be N2 C N2. Similarly, this is 1 N1 C N1. Similarly, N2 to the power N2 or N2 C N2. So, if you calculate sample means from all these possible samples, it will result into x1 bars. You will have so many x1 bars. And similarly, if you are calculating sample mean from these samples, you will have x2 bar. So, if you generate an other table, something like you report x1 bar over here or here and x2 bar over here. So, you will have so many x1 bars and so many x2 bars. If you find the difference, x1 bar minus x2 bars, if you subtract all these samples mean from the first x1 bar, you will get this column. Similarly, if you subtract all these sample mean with the second x1 bar, you will get this column. In the same way, you will get this entire table of x1 bar minus x2 bar. So, if you apply this same process you did in the previous lecture, for example, x1 bar minus x2 bar, then tally, then frequency, and then f of x1 bar minus x2 bar. Then this table is called sampling distribution for the difference between two sample means. To understand this properly, let us take an example. This is the question, this is the example. Population 1 consists of 5 numbers 2, 4, 6, 8, 10. Similarly, population 2 also consists 5 numbers. These numbers are 1, 3, 5, 7, 9. The question is, draw all possible samples of size N1 is equal to 2 and N2 is equal to 2 without replacement, and construct sampling distribution for the difference between two sample means. So, let us do it. Since sampling is sampling without replacement, possible samples in each case it will be n choose n, which is equal to n1 choose n1, which is also equal to n2 choose n2. The reason is both the population sizes and the sample sizes are equal, and by formula this is equal to n factorial divided by small n factorial into capital N minus small n whole factorial. So, this is equal to 5 choose 2. If you solve it, this is equal to 5 factorial divided by 2 factorial into 5 minus 2 whole factorial, or this is equal to 5 into 4 into 3 pictorial divided by, this is 2 pictorial, which is equal to 2 into 1, and 5 minus 2 is equal to 3 pictorial. This is cancel out and this is equal to 10, because 2 is cancel out with 4. So, you will have two possible samples, each for population 1 and population 2. Let us bring these possible samples up front. How? Look at it. This is population 1 and here is population 2. Samples in population 1 are, and samples in population 2 are. Population 1 is 2, 4, 6, 8 and 10. 2, 4, 2, 6, 2, 8, 2, 10 and per 4, 6, 4, 8, 4, 10 per 6, 8, 6, 10, 8, 10. So, these are the possible samples in case of population 1. Let us correct it. 4, 10, then 6, 8, 6, 10, then 8, 10. अब ठीक है, ओके ओके. Similarly, population 2 is 1, 3, 5, 7, 9, 1, 3, 1, 5, 1, 7, 1, 9, then 3, 5, 3, 7, 3, 9, then 5, 7, 5, 9, then 7, 9. Okay. Here you will get x1 bar and here you will get x2 bar. The average of these two value is 3, 5, 5, 6, 5. This is 4. Similarly, this is 5, 7, 7, 8, 9. The average of these values is 2, 3, 4, 5, 4 and 5, 6, and similarly this is equal to 6, 7 and 8. So, all is the possible samples in case of sampling without replacement from the two populations. Now, we have to complete this table. You have to write each and every sample mean. X1 bar is reported in the column, X2 bar is reported in the row. So, this is 3, 4, 5, 6, 5, 6, 7, 7 and 8, 9. 5, 4 and 5, 6, 6, 7 and 8. Okay. चलें अब ठीक है. Okay. You have to subtract all these samples mean from the first x1 bar. If you subtract 2 from 3, you get 1. 3 from 3 0. 4 from 3 minus 1, minus 2, minus 1, minus 2, minus 3, minus 3, minus 4, minus 5. We have subtracted all these samples means from the first x1 bar. Now, follow the same process subtracting all these sample means from the second x1 bar. So, this is equal to 2, 1, 0, minus 1, 0, minus 1, minus 2, minus 2, minus 3, minus 4. In this way, you have to complete the entire table and you will get so done, completed. Now, we have to construct sampling distribution of sample mean from this table. How? Look at it. Okay. Write each and every difference only once. The minimum value in this entire table is minus 5. So, starting from minus 5, minus 4, minus 3, minus 2, minus 1, 0, and the maximum value in this table is 7. So, okay. Now, report all these values. One, 0, minus 1, 1, 0, minus 1, minus 2, minus 1, minus 2, minus 2, minus 1, minus 2, minus 3, minus 3, minus 4, minus 3, minus 3, minus 4, minus 5, minus 5, 2, 1, 0, minus 1, 2, 1, 0, minus 1, 2, 1, 0, minus 1. Similarly, completing the table. So, we are done with it. Now, let us count it. One, 2, 5, 8, 10, 14, 15, sorry. Now, this is completed. Ginle, okay, and it is equal to 100. Okay. Now, we need to compute the probability of x1 bar minus x2 bar. Minus 5 occurs only once out of 100 times. So, its probability is 1 over 100. Minus 4 occurs 2 times out of 100. So, this is equal to 2 by 100, and similarly you can complete it. So, this is sampling distribution for the difference between two sample means. Got it? Sampling distribution for the difference between two sample means.